stretched from now onwards. Now, what we have done till now, that we have been able to do that the a priori algorithm and the FP tree algorithm, and now we're trying to understand that why you cannot apply the support and the confidence levels to generate the rules. Now there are some basic problems with confidence, and though we want that our method of extracting the frequent features should lead to a very high confidence, but a very high confidence of around 95%, 98%, 100% is not desirable. Now, can anybody explain that if I have two items, say A and B, and the confidence of both these items of this rule is say 98%? Is it important? I say that it is not important. Why? Why do I say that? Anyone can give an idea? That a very, very high confidence rule of 98%, 99% or 100% is not interesting. Anyone can
Because
give
it
an
is
idea?
well known fact, maybe like for example, every time we have New Delhi, that will be under Delhi only, so confidence will be high.
No, New
Like
Delhi and Delhi are not two items. Okay, that is okay. But suppose I have an item A in some supermarket, and I have an item B in another supermarket, and say 99%, 100% people are buying those two together. I say that this rule is the confidence of the rule. Suppose the confidence is this. Suppose everybody who buys A buys B also. Okay, then in that case, you get a confidence of 100%. Now, the support could be low. Suppose out of say 1000 person, only 100 persons buy those two things together, A and B. Then the support will be 10 by 100 by 1000, that's 10%. But whoever buys item A also ends up in buying item B, and the confidence is 100%. Now the support is fine, 10% is acceptable. But I say if it is 100% confidence, it is not a good rule. Why it is like this? Because it is obvious. If two things are coming together, it is obvious. Just take an example. I have a word called Hong Kong. Okay. Now, if I apply a text mining algorithm on this document, the word Hong Kong will always appear together. So, I am not talking about in the context of this item set mining, but the occurrence of two words together can be 100% because those two words are related. But you take two other words, those two words may not come in all the documents. Or for example, you are taking a document of computer network. In that document, computer as well as network will come in all the lines adjacent to one another. Now, if those two would have been, therefore, why? Because it's obvious, because these two words are related to that domain, and that is the problem with confidence. Therefore, let me explain this issue, that what are the interestingness measure of to find out those interesting patterns. Now, today we discuss about the pattern evolution. Now, association rule algorithms, as you know, that tends to produce too many rules, but most of them are not interesting or called as redundant rules. Now, what are redundant rules? Now, let us check this one. You check this. You check this rule. You check this rule. You check this rule. And you check this rule. They will have the same support and the confidence. Why? I will have the same support and the confidence because the right hand side is a subset of left hand side. Because here you get AB and here you get ABC. Now the left hand side of the second rule is a subset of the left hand side of the first rule, and therefore they will have the same confidence. Therefore, these are redundant rules. These are redundant rules. Therefore, redundant rules are not should not be taken into consideration. Second is the uninteresting rule. If the pattern that is revealed does not offer any useful information, we call that it's an uninteresting rule. But the problem is you cannot define the uninterestingness in a very simple words. You have to find what is interesting, and therefore it is difficult to define. Okay. Now, how will you define that? Okay, that could be used. You can use you could require a human analyst, or that means you require some human intervention to define that whether it is important or not important, or if I say it is interesting or not interesting. Therefore, if it is a subjective measure, you require human analyst. If it is objective, rely on the data. Now, what is objective and subjective? Anybody has an idea? When I say objective measures, and if I say subjective measures, objective measures are always true. Is always true. Whereas subjective measures depend on the person to person. For example, if I tell that today the weather is hot, if I say the temperature is high today, now you might not agree with me, because for you maybe this temperature of say 30 degree might look to be fine, but for some other person this might look to be hot. Therefore, that is subjective. If I say that this brand of phone is excellent, you may say this brand is not that good. It is all subjective measures. Whereas objective measures are always true. For example, if I say New Delhi is the capital of India, this is an objective statement. If I say the height of Mount Everest is 8848 meters, this is an objective measure, because already everybody will have the same thing. And if I say Narendra Modi is the Prime Minister of India, it's a fact. It's an objective measure. Therefore, why I am going to say this, when I say this objective measures, is always true. Therefore, you have to rely on the data. Whereas for subjective, you have to rely on the human analyst. Okay. Now, if you take the formulation of the association, in our original formulation, association rules, support, and confidence are the only measures which we have used till now. Now, just come to the thing. Now, how we are going to compute the interestingness measures? Suppose you are given this rule, and you have to make a contingency table from this, depending on the interestingness. Now, you have to make a contingency table. In order to make this contingency table, you have to take the information in order to compute the rule in interestingness. Now, there are two things. You are having an X, not X, Y, and not Y. And this contingency table will be 2 into 2. Why? Because there are only 2 items. Now, this entry of this one will have only those items which are having F11. That means it will have the value of X and Y, which are both true. So this one will have the value of X as true and Y as false, and so on. And this will be having like this. All these 4 values will be there. Where F11 is the support of X and Y. F10 is support of X and Y bar, and so on. And you get all these things. Now in this one, I can define the support and the confidence and the lift also. Okay. Now, if I am going to make the contingency table over here, this will now if I would have say three rules. If I have a rule which contains say three items, I will have a 3 into 3 contingency table. Now, based on this particular contingency table, I can calculate the support and the confidence on the lift and the Gini as well as the J measures. Now, let us see how we are going to do this. Now, suppose I take this table. Now, this is the contingency table for x follows y, and for this I am having a tea or coffee. Now, the association rule which I am going to mind is whoever drinks tea also drinks coffee. That means tea and coffee is going together. And I have this contingency table where I have 15 people who drink tea and coffee, 5 people who drink tea but don't drink coffee, 75 are there who take coffee but do not take tea, and 5 people are there who neither take tea and neither take coffee. And this is the contingency table for tea and coffee. And I want to find the association rule for this. Now tell me, what is the association rule for tea coffee? What is the percentage you will get? How many people are there? It's simple. 100. Here the number of persons. Because if you sum up all this, this will give you 100 only. This will give you 100. Now the association rule for tea and coffee will be how much? 0.15. Which is nothing but 15 by 100. Now that means like this. But let us try to find the confidence of coffee and tea. Let us try to find out the confidence of coffee and tea. It is how much? How many person drink coffee? बताओ
15 sir.
80
नहीं
15
कितने लोग कॉफी पीते हैं ऐसे
90
or 90.
90
हमको कॉन्फिडेंस मालूम करना है इसका देखो ऊपर में तो 15 आएगा बिकॉज कॉफी और टी पीने वाले 15 है ना नीचे में 20 क्यों आया ये वैल्यू क्यों आई
सर जितने लोग टी पीते हैं
सर जितने लोग कॉफी और टी दोनों पीते हैं मिला के कॉम्बिनेशन
that means whenever you are having that value where people who drink coffee also drink tea okay तो ये 5 कौन से लोग हैं who drink tea but do not drink coffee है ना therefore people who drink coffee and also they drink tea they are 15 but there are 5 person who drink tea but do not drink coffee therefore the total number of people are 20 who are having that value therefore this confidence is 0.75 अगर हम मान लो इसका ये निकालते हैं ये तो तुम क्या देखते हैं कॉफी नॉट टी देन यू विल चेक दिस वन you will check this one you will check the 75 divided by
80 all the people who don't drink tea
all the people who drink coffee but they may or may not drink tea now अगर तुम इसका सेक्शन रूल निकाल लो तो लेफ्ट हैंड साइड में कॉफी है दैट मीन्स तुमको देखना है वो लोग जो कॉफी पीते हैं और चाय पीते भी है या चाय नहीं भी पीते हैं, दोनों चलेगा, बिकॉज कॉफी पीना चाहिए। कॉफी पीने वाले कितने लोग हैं?
90।
जो लोग कॉफी पीते हैं वो 90 लोग हैं, because they're 90 over here. Therefore, in that case, you have to take like that, like this. Therefore, because जो कॉफी पीते हैं वो यहाँ पे आएंगे ना, वो नीचे इसके आएंगे, बिकॉज ये कॉफी पीने वाले हैं ना, विदाउट दैट इज दीज आर पीपल। ये जो है वो है जो कॉफी पीने वाले हैं 90। ये हैं जो कॉफी नहीं पीते हैं 10। ये हैं जो टी पीने वाले हैं। ये हैं, ये कौन है ये वाले बताओ? 80 कौन है?
जो टी
नहीं पीते हैं।
जो टी नहीं लेते हैं वो 80 है, जो टी नहीं लेते हैं। उसमें 75 वो लोग हैं जो कॉफी लेते हैं बट टी नहीं लेते हैं, और 5 लोग ऐसे हैं जो ना टी पीते हैं ना कॉफी पीते हैं। Now this is the whole thing. Now what is the probability of people drinking coffee? Simple, 90 by 100. Total number of people are 100, and 90 are the one who take coffee. Therefore 90 by 100. Now if you are going to see the confidence of this rule, you find that the confidence is high. You find that the confidence of this rule is high. It is around 75%. But if you see, actually coffee और टी नहीं पीने वाले लोग जो हैं, they are 93%. Now actually यहाँ पे I'll just remove this because ये हमने कर दिया ना, इससे confusion हो। Now you just see. Now this rule which I am going to use over here is having this rule over here is having a 75% confidence. So this shows that people who drink coffee as well as tea are 75%. But in actually 93% people are there who drink tea, who drink coffee but do not drink tea. So this rule is high, but it is misleading. Why? Because there are 94% people who do not drink tea. Therefore, actually you do not drink tea in this rule, but drink coffee. Therefore, sometimes a high confidence rule may be misleading. Are you getting the point? That confidence do not always give you a very true nature of the whole scenario. You have to reduce the things from the other things also. Therefore, even the confidence of this rule is high. This rule does not says all. It is going to, because ये जो rule high हो रहा है because of the people who drink coffee and not because of people who drink tea. This rule 75% जो आ रहा है, ये इसलिए आ रहा है कि लोग कॉफी पीते हैं ज्यादा। उसमें से दोनों पीने वाले ठीक है, ये this rule will come over there. But जो टी पीता, जो कॉफी पीता वो टी पीता होगा। Obvious है, they drink every type of beverages. But actually कॉफी पीने वाले नहीं, चाय नहीं पीने वाले वो 94% है। बट तुमको इस रूल से लगता है कि ऐसे लोग बहुत ज्यादा हैं जो कॉफी और चाय दोनों पीते हैं, isn't it? If you see 75%, it will look that people who drink coffee and tea are very much high. But actually 94% वो लोग हैं जो कॉफी पीते हैं बट चाय नहीं पीते हैं, और 75% लोग वैसे हैं जो कॉफी और चाय दोनों पीते हैं। इसका मीनिंग ये हुआ कि ये जो आई कैन डिड्यूस लाइक दिस, कॉफी पीने वाले जो लोग होते हैं वो मैक्सिमम लोग जो है चाय भी पीते हैं, and therefore the confidence of this rule becomes higher. But if I dig deep, I find that people who drink coffee, 94% of them do not drink tea. यानी जो बाकी जो परसेंट है लोग, जो 6% है, वो सारे बेवरेजेस पीते हैं। Okay, this is the drawback of confidence. If we just see one rule, that rule might be misleading. if you do not see this one, if you do not see this rule, this will look to be a very good rule. But if I see this rule, I find that this rule is misleading. Is it clear? Fine. Now, let us try to find the statistical independence things. How will I be able to check whether those, the things what I want to find are statistically independent or not? Now, suppose there are 1,000 students anywhere. Out of them, 600 students know how to swim, 700 students know how to ride a bike, and there are 420 students who know how to swim as well as to bike, as well as to ride a bike. Okay. Now, out of this, I want to find over there that is swimming and riding bike is statistically independent or not independent. Now, let us try to take this into think how I want to calculate the person who knows to swim as well as to ride the bike. And how many of them are there? It's so simple. 420 divided by 1,000. That means I get it to be 42%. Now, if I calculate with the probability of people who knows to swim as well as to know how to ride a bike, this will be 0.6 into 0.7, which is nothing but this is 600 by 1,000 and 700 by 1,000, and this will be coming to 0.42. Now, in that case, these two values looks to be are same, and if this formula is satisfied, I say that these two are statistically independent. That means if the probability of S and B is equal to probability of S multiplied by probability of B, I say that S and B are the statistically independent. That means you cannot infer from this data that people who know to swim can also ride bike. Is it clear to you? That from this data I cannot infer that swimming and bike are related, are dependent. Okay. Okay. For example, if I want to have an idea that people who do good in maths also do good in science. Suppose I have this particular, I want to find it out. Those people who do good in maths are also scoring very high in science. Now, for that, I have to have some statistics. That how many percentage of how many students I am going to see, how many of the students who scored good in maths, how many of them scored good in science, and how many of them scored in both. And then I want to find. But if this formula is if I find that both are same, the people who scored good in maths and people who scored good in science with the people who scored in both are same, I said that this is it is independent. Now, if I want to check the other one, suppose if I have 1,000 students, the same data, but here I find this value that there are 500 students who know how to swim and as well as to ride a bike. Now, here I just change this. I change from 420 to 500. Rest of them are same. 600 students know how to swim, 700 students know how to bike, but 500 students know how to do both. And then now I calculate. Obviously, this will not change. This will be same. But if I take this one, this value comes to 0.5 because this is by 500 divided by 1,000, and I get this that the probability of students who know to swim as well as to ride a bike is greater than probability of students who know to swim and multiplied by probability of students who know to bike. And I find that the left hand side is bigger than the right hand side, because on the left hand side you get 0.5 and the left hand side you get 0.42, and I can say that this is positively correlated. That means there is some correlation between student who know to swim as well as the same student who know to bike.
हाँ बोलो.
Okay. Now with this one, I will be able to find that these two are positively correlated. Now, if I do the other way around, if I decrease the number of students who know to swim as well as to do ride bike, now again do this like this. Now I do it that I only know that there are only 300 students who know to swim as well as to ride a bike, and I get this table, and I find that this value is less than this value, and if this is the case, this is negatively correlated. That means people who know to swim, they do not know how to ride a bike. Now I will be having a negative correlation between swimming and riding bike. Okay. Now this is a phenomena which is important, that I want to find the relationship between I better to say correlation between two things which may be statistically dependent or independent. If it is dependent, it will be either negatively dependent or positively dependent. Okay, now I ask you a simple question. Can you give any other example in the real life where you find that there is a negative correlation between two items?
So price and demand of any product.
No, give it from the domain of buying something. Give it from buying something. There are a lot of them.
Sir, milk and juice. Maybe.
Could be that people, if you have already had a milk, you will not have to. Therefore, this could be one. One of the very important. Anyone can give a other one acceptable. Maybe if I take into consideration, this might be true. But one example I want to hear from you, which will always be negatively correlated.
Sir, two products which are like same thing being produced by two competitive companies, like Real and Tropicana juice.
No, those are same things. No. Of course, you cannot say that, because those are all juice only. Don't take the brand.
Sir,
with two
sir,
items.
soft drink or milk.
Okay, that's almost
Milk
same.
and beer.
Okay,
Or
okay,
soft drink or medicine.
that has to be actually. Now, one of the very good example is a desktop or a laptop. Normally, if you buy a desktop, you won't buy a laptop, or vice versa. Therefore, if I find that if I say 1,000 students are there, how many students bought laptop? How many students bought desktop? Then in that case, if you want to find that, in this case, buying of laptop and buying of desktop will always have a negative correlation, because if one is going to buy one thing, it is 100% or maybe 95%, 90% it must be correlated. Sorry, negatively correlated. Now, how you are going to find a correlation? The correlation is defined from the value of -1 to +1. If it is more on the negative minus side, it is highly negatively correlated. For example, if I give you -0.9, it means that these two items are highly negatively correlated. If I give you -0.1, it is negative correlation, but not that strong. Weak correlation, weak negative correlation. If I tell you +0.85, it is highly positive correlation. That means if you buy this thing, you will always buy this thing. Okay. For example, if I take some say if I for the example of say marks of maths and science. Now I can say that students scoring high in maths also score high in science, and this is having a positive correlation of 0.85. Okay, it means that if I take all those students and try to find it out, I will get 85% case. I will get that these two are having high correlation. Now this is how you are going to use this method to find out correlation. If it is near to zero, say it is minus 0.5, 0.1 or minus 0.2 or plus 0.1, plus 0.2, you cannot infer much. Though it is negative, if it is 0.1 also, if it is negative 0.02, it's okay. But you cannot very much infer from that. Therefore, it has to be around more than around 0.5. Either on the positive side or the negative side. If it is minus plus 0.5, you can say it is somewhat strong. If it is say plus 0.5, it is say somewhat positive correlated. Okay, this is how it works to be. Now if I am going to let us try to find the other measures. One is called the lift. The lift is defined by this formula which is given over here. You can find lift by this formula, P of x comma y, Px into Py. Okay, that means you have to calculate over there the probability of x comma y, the probability of x, and the probability of y, and divide the probability of x comma y by probability of x comma into probability of y, and this is called the lift, or also called as the interestingness. Now, if I am going to do in the case of text mining, I just give an example of a word called Hong Kong or a word called computer network. If I am going to use this, I will using the word called as a very important word called the PMI, the point-wise mutual information. That means if those two words are coming together, it is P comma x comma y. If P of x is the word coming alone and Py coming alone. For example, if I take, let us take the probability of Hong Kong. What is the probability of, say, coming of Hong Kong in together? Suppose it is say 100. What is the probability of coming alone? If it is same, over there I will get something around 1. Now I say that the mutual information over there is very, very high. Okay. Now if I do another evaluation called as the Patesky-Shapiro method, which is called a PS method, where I want to find that if I have to find that you want to find the probability of x comma y minus probability of px into py, this is called the Patesky-Shapiro measure of statistical measure. Okay. Now all these measures are division from the independence. Now if it is higher, it's better. Why? Because if it is higher, it tells you either a positive or a negative correlations. I told you 0.2 plus 0.2 minus 0.2 is not that important. Now just what I explained, I'm just coming to this. Okay, now let us come back to the same contingency table. Now here I am having the same data and I want to find the lift. Now the formula for lift is P of x comma y divided by P of x into P of y. Now here P of x comma y is 75. Okay. Therefore, in that case, I want to find over here like this by 19. How many persons are there who drink coffee? It is 75. Why? Who do not drink, obviously they do not drink tea. Therefore 75 by 90. And this comes to 0.833. Therefore it is less than 1. Therefore it is, in this case it is negatively associated. Now if I take into where with this value, this point over here, if I take this value, it is 0.5 divided by 0.9 into 0.2. If I take this 0.9 multiplied by 0.2, now in this case you get px into py. Now this is px, this is px, this is py. Therefore, since I take coffee first, now this is px, and this is py. Therefore, px, I get this value. Now let's take this in the case of documents. Now suppose I have some documents, and here I find that what is the probability of having a word of and the together. And I find that the probability of having of is 9.9, the probability of having the is 0.9, the probability of having of and the together is 0.8. And I find that these are almost same. The probability of having of the is approximately same as the probability of having of and the. And therefore, we say that it is just by, that is not, this is appearing together by chance. If it is having the more or less the same probability of appearing together, it is basically by chance. Now in this case, you cannot say that this is a high correlation. Now let us take the other way. Therefore, we will say that this is having no correlation. It is having no correlation. Now if I take the other way, now the word which I told you, the word Hong Kong is coming to 0.2. Hong is coming 0.2 times, Kong is coming 0.2, Hong Kong comes 0.19. And if you multiply this, the probability of Hong Kong is much greater than probability of 0.2 into 0.2. Why? What is the probability of Hong Kong? It's 0.19. Probability of Hong is 0.2 multiplied by 0.2, that is 0.04. The 0.19 is much bigger than 0.04. Okay. Now in this case, we will say that it is a positive correlation, isn't it? यहाँ पे क्या था? Are you getting it? Make it very clear. Just a moment. यहाँ पे क्या था? It was 0.81, 0.8. यहाँ था approximately equal to 0.9 multiplied by 0.9. दोनों 0.81 हो गया, ऑलमोस्ट सेम है. यहाँ पे क्या हुआ? 0.19 और यहाँ हो गया 0.04. Therefore, the left hand side is much bigger than the right hand side. Therefore, it means that it is having. Therefore, therefore Hong Kong have much lower probability to appear together by chance. Therefore, it means that two words appear almost always together. Therefore, these two words will always occur together. Now, in the other way, suppose I have a word called Obama, which is having a probability of 0.2, and a word called as Caragonis. You know who is Caragonis? Obama, everybody knows. Who is Caragonis? He's a footballer. Okay, he's a footballer from Greece. Okay, now if I take Obama and Caragonis together in some document, the chances for them occurring together is only 0.001. And if I calculate the probability, I'll get something over here. This value comes to 0.4, 0.04, and this value comes to 0.001. And the right hand side is much bigger than left hand side. That means it is negative correlation. That means it is having a negative. Therefore, these two words will almost never occur together. Okay, that means Obama and Karagunis have much higher probability to appear together. Therefore, by chance. Okay. Now, the word which you must see over here is the word which I am going to say. Here it says that it should be, now you have to just check it out, the words which I used. It should be same over here. It is lower. This is high. If it is same, it is no correlation. If the left hand side is bigger than the right hand side, it is positive correlation. If the left hand side is smaller than the right hand side, you say negative correlation. Now, from where did I get this? From some documents, I found the probability of having an off. Suppose I get 10 documents. Out of those 10 documents, in 9 documents I found the word off. Therefore, the probability is 0.9. Again, I found the probability of the 9 out of 10 times. It's 0.9. The probability of having off and the together in both the documents. Sorry, both the words in the document. It is say 8 out of 10. The 0.8. And I get all this from the simple word searching from a document. Okay. This is how you apply in a document, not in an item. Okay. Is this clear to you? Now, there is some drawbacks of lift also. Now, if I have such a data where I have a fraction of documents containing honk as 0.0001 and here like this, and I find the mutual. Now here this MI stands for mutual information, and I find this value of 0.0001 and I get this value to be 10,000. And I am going to use for this again by this value, and I get the MI of this value as say 4.75. Now here, rare co-occurrence are more interesting. Rare co-occurrence are having more interesting. Therefore, sometimes if I find something which is rare, that is more interesting than what I want to find. Now you find the MI of this is very higher than this value. And this value of 10,000 is much higher than the value of 4.75. Therefore, if I want to find the occurrence of this Hong Kong, it is 0.75 the MI, where the word Hong Kong is 10,000. And that word appearing together is called a rare co-occurrence. Now that means sometimes I want to find those words which are more important, which are rare, and those words are more important for us than to take those words which are known. Any questions you want to ask? May please.
सर ये रिकॉर्डिंग्स कैसे अवेलेबल होंगी? जैसे लॉगिन आईडी पासवर्ड मिल गया है वहां से.
It will be available. The only thing is that if I upload in a classroom, It is not allowing me to share in the. Therefore, what I want to do, I will try to upload on the YouTube, so that you'll be able to. Otherwise, it is not. This organization not allowing me to. It's not sharing outside. It's not allowing. Therefore, for that I have to upload in Dropbox, and from there you have to download. Now, that will be difficult because one of the videos around takes around 600 to 700 MB. Therefore, for that you have to every time download it from your Dropbox or from the Google Drive. Therefore, I'm trying to do it today. Therefore, today I'll at least upload 2-3 videos. Now, any more questions? Please ask.
So this chapter in association rule mining